Hey guys, welcome again to the Maths Club. If you are just joining us, so welcome. So we're starting a brand new series on indices. But before we begin, I want us to look at the journey so far in terms of how far we have gone in the WAEC syllabus. So this is WAEC syllabus here. So if you look at the WAEC syllabus, under number and numerations, this is like the first major topic, right? So we've covered number bases, we've covered modular arithmetic, we've covered fractions, decimals, and approximations. And now we're in indices. So in indices here, we're going to be looking at the laws of indices, and we're going to be looking at numbers in standard form, right, or scientific notation. So basically, this is how far that we have gone. So let's go back to where we're coming from. So what are indices? When you hear indices, what do you mean by indices? Let me use some example to actually portray what I'm talking about. So imagine if you wanted to multiply 2, like 2 times 2 times 2 times 2 times 2 up to like maybe 32 or 32nd value, right? So you're having 2 up to like 32 values, right? So you agree with me that that is very long. So one way that we can do it, we can just say 2 raised to the power of the number of 2's that we're multiplying, which is what? 32. And you see that just this very short way of representing the same thing gives us the same value at the end of the day. Also, if you have a very large value, right, let's say we resolve this raised to the power 32, we have a very large value. Let's see what it will give us. So if I say, on them say 2 raised to the power 64, right? So you can see 2 raised to the power 64 is a very large value. So instead of writing this very large value, right, I could just say 2 raised to the power of 64, right? You can see that it's actually easier. And all this power is being given to us by indices, right? So let's look at what indices is in general. So it says indices are like shortcuts for repeated multiplication. They help us to express big numbers or repeated multiplication more easily. And indices or exponents in mathematics are a way to show repeated multiplication in a compact and convenient form. And you can see all these things are very true based on the example that we started with. So there are laws of indices. So you could check different textbooks, there may be different numbers of laws and everything, but basically there are 7 things that actually define indices. So the first is that if you have x raised to the power a multiplied by x raised to the power b, it's simply saying x raised to the power a plus b. And we're going to see that in action. So if I have 2 raised to the power 2 times 2 raised to the power of 3. 2 raised to the power of 2 is 2 times 2. Multiplied by 2 raised to the power of 3 is 2 times 2 times 2. Right? You know what I said before? We could just say 2 raised to the power, since it's 2 raised to the power of how many? 1, 2, 3, 4, 5, 2 raised to the power of 5. Right? That means that I could have just said, since they share the same base and the multiplication, that would be, I can just say 2 raised to the power of, and I will add their powers, and that would be 2 plus 3. Right, so that's 2 raised to the power of 5. So you can see we had the same thing. So this is in line with the rule or with the law of indices that x raised to the power a times x raised to the power b is equal to x raised to the power a plus b. Great. Now let's look at what happens when it's division. Let me use this example of 2 raised to the power of 5 divided by 2 raised to the power of 2. Right, so 2 raised to the power of 5 is 2 times 2 times 2 times 2 times 2. Divided by 2 raised to the power of 2 is 2 times 2. You agree with me that I can slice, so 2 will cancel here, 2 will cancel here. I'll be left with 2 times 2 times 2, or 2 raised to the power of 3. Right, so also too, if they share the same base, right, 2, we could just say 2 raised to the power of 5 minus 2, and that will give me 2 raised to the power of 3. Right, so I mean that's a very short way of doing it. You can see once they share the same base and it's division, you can just subtract their powers. So the third rule is saying x to the power of 0 is equal to 1. That means anything raised to the power of 0 is equal to 1. How do we know that this is true? Let's do some analysis. So if I have 5 raised to the power of 3 divided by 5 raised to the power of 3, I could have said 5 times 5 times 5 divided by 5 times 5 times 5, right? And cancel, 5 will cancel here, 5 will cancel here, 5 will cancel here, 1, 1, 1. So it's like 1 times 1 times 1, which is giving me 1, right? Or alternatively, if I know the laws of indices, I could say 5 raised to the power of 3 minus what? Minus 3, and that's 5 raised to the power of 0. And you can see, because 5 raised to the power of 0, I must have the same value either way. So you can say anything raised to the power of 0 is equal to 1. So whenever you say anything raised to the power of 0, equates it to what? To 1. Great. So for this number, the fourth row, allow me to talk about the fifth row first, and I'll come back to the fourth row. So what's this fifth row? This fifth row is saying x raised to the power of a in brackets b. Like if you have this kind of situation, you can just multiply the powers and say a times b. So an example is I have 2 raised to the power of 2 open bracket 3, right? So that is, or let me say open bracket 3, right? That's like saying 2 squared times 2 squared times 2 squared, abi? And look at it, 2 squared is like saying 2 times 2 times 2 times 2 times 2 times 2. So if I say 2 raised to, how many 2's do we have? We have 1, 2, 3, 4, 5, 6, 6, right? So that means that if I have something like that, I could say 2 raised to the power of 2 times 3, right? That will give me 2 raised to the power of 6. Great. Now let's go back to the fourth one that I talked about. We already know that if I have 5 raised to the power of minus 1, that's like saying 1 over 5, right? If I have 7 raised to the power of minus 1, it's like taking the inverse, that 1 over 7. That is fine. Now we have x raised to the power of minus a, right? So x raised to the power of minus a. From the fifth row that we know that this, I could separate and say x raised to the power of a, right, then minus 1, right? From this one that we have here, 2 raised to the power of 6, 2 raised to the power of 2, then 3. As far as if I multiply these two, I'll be able to get this power back. I can be able to do that, right? Since I know this, I will know that anything raised to the power of minus 1 is 1 over that thing, right? I could just say this is also equal to 1 over x raised to the power of a. Great. So if I have, for example, like 5 raised to the power of minus 2, I could say this is like 1 over 5 squared, right? So that actually perfectly makes sense. Let's look at the sixth row. So we have x raised to the power of 1 over a. X raised to the power of 1 over a. Whenever we have something like this, right, it's just like saying take the 8th root of x. So I could just say x like the 8th root. So if it was 5 raised to the power of 1 over 2, that's like saying take the square root, right, of 5. If it was 5 raised to the power of 3 over 2, right, I could break this into 2 and say 5 raised to the power of 1 over 2, abi, then cube, right? But 5 raised to the power of 1 over 2 is square root of 5, right? And then I would raise it to the power of 3, right? So that is like an advanced form of the application. But once we know that, if you have, so another example, if you have 7 raised to the power of 1 over 3, right? Can you guess what this would be? Great, you got it, right? That would be cube roots of 7, right? So this is basically the row 6. And of course, we've actually talked about the row 7, right? X raised to the power of b over a is the 8th root of a raised to the power of b, right? If you need further example, this particular one talks about it, where we said we could split it into 2 and say 5 raised to the power half cube and do the square root of 5 and raised to the power of 3, right? Because it's very, very similar. So that is it about the 7 laws of indices. If any of these things are not clear, please watch the video and rewatch it till you get it very well. So in the next video, we'll be talking about more examples using these laws of indices. See you guys there.